This is part 2 of the 2.06 notes, and we finished up with looking at how to do the math for it, and so I put it in our notes. So start here. What's the molarity of a 100 milliliter or 0.1 liter solution that contains 2.94 grams of dissolved sulfuric acid, which is H2SO4? Always start with what you know. So we know that we have 2.94 grams dissolved in 0.1 liters. Remember, you do need to change it to liters, and so we put in our note 1 liter equals 1,000 milliliters. So if I only have 100 milliliters, I have 0.1 liter. What has to be on the top of the next fraction? It has to be liters, because remember, in stoichiometry, we always have to cancel things off. But this is where this one gets tricky, okay? And these are a little bit different because we're thinking that, oh yeah, we should put liters on the top, but that's not actually what we're going to do this time, okay? So if you're like, no, here's why. You also need to look at what we want our final unit to be. So what do we want our final unit to be? We want our answer to be in moles per liter. Okay, so we already have the liters on the bottom, so we have to get rid of the grams. So that tells us we need to put grams on the bottom of the next fraction and moles on the top. Because if we look here, our grams cancel out and we're left with moles per liter. Okay, so it's a little bit different in our setup. We want to really make sure we know what do we want our final unit to be. All right, so then we have to find the molar mass. And so we did that by saying that there's 2 atoms of hydrogen, each one weighs 1. There's only 1 atom of sulfur, and it weighs 32 grams. And there's 4 atoms of oxygen, they're each about 16. And our answer is 98.1 grams per mole. All right, so we put that on the bottom, so our grams canceled. So there's 98.1 grams per mole. And we're left with our unit of moles over liters, or molarity, which we can abbreviate as a capital italicized M, and our answer is 0.3. Okay. Try working through another molarity problem. So we did this one. Again, if you didn't get it, watch it again, go through it again. If you're still having problems, please come see me so I can help you with these. Concentration can also be expressed as a mole fraction. The mole fraction is a measure of the number of moles of one component of a solution divided by the total number of moles in the solution. The component can be either the solute or the solvent in the solution. Okay, so in other words, we can do the mole fraction for solute. We take the moles of solute divided by the total moles of the solution. Or we can do the mole fraction for the solvent. We just take the moles of solvent and again divide it by the total moles of solution. So in a way, it's kind of like finding a percent. It's a ratio. There are no units in the answer to a mole fraction problem. The moles in the unknown are canceled out by the moles in the total solution. So in our notes, I put in there concentration can be expressed as mole fraction. The mole fraction is a measure of the number of moles of one component, so either the solute or the solvent, and it's divided by the total number of moles in the entire solution. And I put these in there because I thought that this was easier to make sense of than the paragraphs. And it says mole fractions for solutes and solvents are determined by dividing the total number of moles. And that's our next slide. So try working through a mole fraction example. Industrial exhaust gas contains 128 grams of sulfur dioxide, SO2, dissolved in 1,500 grams of carbon dioxide. What is the mole fraction of SO2? Step 1, find the number of moles of the solute, okay, because that's what we're asking about. We're asking about the mole fraction of the SO2. So that's what's going to go on the top of our final fraction. So to find that, we need to say that, okay, we have 128 grams. And then we need to figure out what the molar mass of SO2 is. So you look on your periodic table, the molar mass of SO2 is 64.04 grams. and then we do our math, and it ends up being 2 moles. So this one is set up as 1 fraction. I'm going to show it in our notes as set up as 2 fractions. So we started with what we were given. We were given 128 grams of SO2. So what goes on the bottom of our next fraction? Again, it's going to be grams, specifically of SO2, so that those cancel. And on the top is going to be the mole, because that's what we want our final unit to be. We want to know how many moles of SO2. So you put it in your calculator, 128 divided by 64.04 gives you 2 moles. And just as a reminder where we got this from, we got this from the periodic table. Okay? All right, step 2. Step 2 says find the number of moles of the solvent. So we have moles of carbon dioxide. And again, they set it up that same way. If we look back at our original problem, we have 1,500 grams of carbon dioxide. And then they divided it by the molar mass of carbon dioxide to get 34.09 moles. And again, I will rewrite it in our notes to kind of set up in the format that we're more used to seeing. So again, we started with 1,500 grams of CO2. We put grams of CO2 on the bottom of our next fraction. We know that 1 mole of CO2 is equal to 43.99 grams. We got that because on the periodic table, carbon weighs 12. Each oxygen weighs about 16, and there's 2 of them. So 16 times 2 plus 12 is going to give us 44. They kept it to the decimal points, so 43.99, which again is more accurate and better to do that way. All right, so that tells us that we have 34.09 moles of CO2. Now we want to know what's the mole fraction of SO2. So if we go back up, we know that we want the moles of the solute divided by the total moles of the solution. Okay, so in other words, we want moles of SO2 because in this story problem, they ask you the mole fraction of SO2. So that's going to go on the top, the number of moles of SO2 divided by the total number of moles of the solution. So we have to put 2 plus 34.09. So it's the number of moles of SO2 plus the number of moles of CO2. Make sure you put it in your calculator correctly. If you notice, they have parentheses for order of operation, or you can just add it and write 2 divided by 36.09. And the mole fraction is 0.06. And that's it. That's your answer. There are no units because the units were mole and they all canceled off. Now, as a reminder, just listening to me going through these is not enough to make sure you learn them, okay? After you're done with the recording, you should go back and make sure you can do them on your own without looking at anything. So just look at the problem, figure out the entire answer, and then check your answer. If you didn't get it right, read through it, see what you did. Then try it later in the day. Okay, that's the only way you're really going to learn these. So many people listen to me, the recordings I had after first semester, they're like, I don't get it. I listened to your recordings, I understood it, and I failed the quiz. Yeah, well, it's a lot easier when you listen to somebody explain it, but can you go back and do all these problems on your own? That's how you can tell if you really learned it. All right, next slide. So now it says look at some model problems. And actually, you know what? That was for honors chem. So I don't think you guys need to do that. I'm going to double check. Okay, yep, you can ignore that previous slide. We'll be doing some problems in a later lesson. So as a review, concentration is expressed as grams per liter. It's expressed as a mole fraction, which is moles per mole. Concentration is also expressed as molarity, which is moles per liter. Molarity and mole fraction are 2 ways in which the concentration of a solution can be described. Molarity is a way to describe the concentration of solution as the number of moles of solute dissolved in 1 liter of solution. I know it says I wish they would have wrote 1. People don't realize that it's so important that it's 1 liter of solution. The amount of solute must be expressed in moles. Mole fraction is the number of moles of either the solute or the solvent divided by the total number of moles of the entire solution. There are no units when solving a mole fraction problem. These are just 2 of the ways that the concentration of solution can be expressed. And that's it for this unit, except to go back and practice.